Now we're going to take a look at solving equations where there's a multiplication involved. Let me show you what I mean with an example. Let's find the solution to this equation, 5x equals 15. Now, first of all, I just want to remind you something. This is just between us. But remember what 5x actually means. It actually means an invisible times. It's technically 5 multiplied by x. So there's an invisible multiplication that's understood here. So this is 5 times x equals 15. Okay, now how are we going to solve this? Well, the strategy is the same as before. What we want to do here is think of this as a perfectly balanced scale. And what I want to do is work on one side so I have x all by itself, x equals the number. Because x is some unknown number to us, and we want to find it. So what we have to do is we have to figure out how we're going to undo multiplication by 5. Well, what's the inverse of multiplication? It's division. So I want to divide this side by 5. Well, great. Divide this side by 5. But I'm going to be in trouble if I stop there. Why? Because by dividing one side by 5, I'm going to lose the balance that we had. If you do an operation to one side of an equation, you've got to do it to the other. That's just a fact about life in math. So if we do it to this side, we've got to do it to this side. And now we're in good shape. Well, now notice that 5 divided by 5, that just cancels and I get 1. So I have x equals, and 15 divided by 5 is 3. So there's my answer, x equals 3. And the question is that the correct answer? Well, it's easy. We can actually check to see. How would you check? We'll just replace this unknown x by this 3 and see if the original equation is satisfied. So let's check it. So if we check, it's sort of cool. You can always check and see if your answer's right. We plug in 5, and I'm going to use the parentheses method to indicate the 5 times 3. 5 times 3, I'm hoping it's 15, but look, it is 15. So, ching, this checks. We got the right answer. Great. Let's try another one. 12 equals 3q. Notice that now the unknown is the letter q. Again, you shouldn't be freaked out by this at all. Bottom line is we could have anything substitute for that unknown number at this point. Our job is to figure out what that mysterious quantity is that makes this a true statement. So if it's called q, if it's written on the right-hand side and you're used to seeing it on the left, don't worry about it. Just understand you want to get this unknown by itself. You want to have q equals stuff. How are you going to do that? Well, we have 3 times q. I want q alone, so I've got to undo the multiplication. How do you undo the multiplication? It's division. So I'm going to divide the right-hand side by 3, but to keep the balance equal, I've got to divide the left-hand side by 3. Well, now, 12 divided by 3 is 4, and 3 divided by 3 is 1, so I'm just left with the q, and so I see that 4 equals q. So q equaling 4 seems to be our answer. Let's check. Easy enough. We just go back to the original equation, and we let q equal 4. So 3 times, I'll use the dot now, 4, but that equals 12, which checks. I have 12 here. So the answer, q equals 4, is the right answer.